Hello everyone! My name is Andy Liao and I'm a first-year general biology major here at the University of California, Los Angeles. And today on April 27th, on this beautiful sunny day, we'll be learning about enzymes. Yay! So first and foremost, to answer the question, explain the effect of enzymes on the thermodynamics and kinetics specific to any reaction, we will be looking at this graph. But before I analyze this graph, I would like to make a note that enzymes are biological catalysts that reduce the activation energy by stabilizing the transition state and decreasing the free energy. Enzymes are not consumed, they do not supply heat, and they speed up the process of reaction. Substrates bind to the enzyme active site, which is highly specific, and the reaction is catalyzed. Enzymes aren't indefinite, and they break down and can be replaced. They don't change the start, meaning the reactants, or the end, the products, or that gives free energy, meaning delta G remains the same. The rate or the kinetics of the reaction is sped up and the rate increases. Enzymes lower the energy of the transition state, speeding up the process of reaction. They align the substrate, donate electrons, and stress the substrate. A high activation energy means that the rate of reaction is slow, whereas a low activation energy means the reaction is fast. So as you can see here from the graph, the activation energy without the enzyme is much higher than the activation energy with the enzyme. And this is due to the enzyme. But then with the enzyme, with or without the enzyme, the delta G, or the change in free energy, remains the same. Furthermore, to answer the question, evaluate environmental effects, for example pH and temperature, on enzyme catalyzed reaction rates. We'll look at this graph right here. Enzymes have an ideal pH and temperature. If they are put outside of the ideal zone of pH and temperature, they will not function optimally, and they may not function at all. Typically, if there are more enzymes present, the rate of reaction will be faster, so long as there are enough reactants and products for the enzyme to bind to. As you can see here, the optimum pH for this specific enzyme is 8. And the enzyme activity increases and peaks at the pH 8 and decreases once again. Meaning, in these two areas here, the enzyme activity isn't as effective and efficient as over here. Last but not least, to answer the question, evaluate the effect of regulatory molecules such as feedback inhibitors on metabolic pathways. We will look at these two drawings here. Inhibitors decrease enzyme activity. Irreversible inhibitors usually form covalent bonds with enzymes and thus irreversibly inactivate them. On the other hand, reversible inhibitors form weak bonds with enzymes and therefore easily dissociate from them. Inhibitors can bind to the active site and prevent substrate from binding, or they can bind to sites other than the active site and change the shape and activity of the enzyme. All in all, enzymes catalyze reactions. but they do not change the delta G or free energy of the reaction. And enzymes can be inhibited by regulatory molecules, such as irreversible inhibitors and reversible inhibitors. Thank you so much for tuning in to my discussion on enzymes. Thank you.